Today, we're going to pull back the curtain on a small piece of medical tech that has a huge impact on global health, the dengue rapid test. So, let's just dive right in.
Think about that for a second. It sounds like something straight out of a sci-fi movie, doesn't it? You've got someone with a fever, and you need answers, like now. How is it even possible to get a solid clue about a viral infection in less time than it takes to get a coffee? Well, that's exactly what we're going to unpack.
But first things first, to really get why a rapid test is such a game changer, we need to understand the problem it's built to solve. And that problem is dengue fever.
So dengue is this mosquito-borne virus, and it's a massive issue in huge parts of the world. And when it hits, boy, it can move fast. That's why getting an early diagnosis isn't just a nice to have, it is absolutely critical to manage the illness and stop it from getting really severe. When it comes to dengue, speed is everything. Okay, so if dengue is our culprit, then this little plastic test cassette is our detective. But what clue is it actually looking for? You might think it's hunting for the virus itself, but it's actually looking for a very specific piece of evidence the virus leaves behind. And that clue is a protein called NS1. You can literally think of it as the virus's calling card. As the dengue virus is multiplying in the body, it's shedding the specific protein into the bloodstream. And that's the real genius of this test. It's not trying to find the virus, which can be tricky. It's hunting for this very obvious calling card it leaves all over the place. But here's the catch. And it's a big one. Timing is everything. This calling card is only around in big numbers early in the infection. So this NS1 test is really only effective within the first 7 days after symptoms show up. After that window, the NS1 levels drop off, and this test just isn't the right tool for the job anymore.
So we know what the test is looking for and when it needs to look for it. But how in the world does this little plastic cassette actually do all of that? Let's pop the hood and see what's going on inside.
Okay, the official super technical name is a qualitative lateral flow-based immunoassay. I know that is a mouthful, but I promise you the idea behind it is actually beautiful and, surprisingly simple. Let's just break it down. It all starts with that lateral flow part. Just imagine a drop of the patient's blood serum starting a little journey flowing sideways, laterally, across a special strip inside that plastic case. As it's moving along, it picks up these tiny microscopic things called detector particles. Think of them like little magnets that are coated in a dye, and they have one job and one job only: to grab onto that dengue NS1 protein. And right here, this is the magic moment. If that NS1 calling card is in the sample, these little detector magnets snap onto it, creating this little colored package that keeps traveling down the strip. Finally, this whole package gets snagged by something called the test line, which is basically a fixed trap. And as all these colored packages start to pile up in the trap, a visible line appears. No NS1 means no packages, which means no line. It's really that simple. All right, so that's the science behind it. Now let's get practical. How does this actually look when someone's performing the test? Well, the procedure itself is designed to be super straightforward. You put the cassette on a flat surface, you add a few drops of the patient's serum or plasma, and then comes the really important part. You start a timer, and you wait. In that waiting period, it is not a suggestion. It is strict. The instructions are crystal clear. You have to read the result within a very specific window, usually somewhere between 10 and 15 minutes. If you look too early, you might miss a positive. But if you wait too long, say after 20 minutes, you could get a false result. So for accuracy, that timing is absolutely non-negotiable. Okay, the timer's buzzed. It all comes down to interpreting those little pink lines. So what do they actually tell us? It's pretty straightforward, really. If you see two lines, one at the Control C position and one at the Test T position, that means it's positive. The test found the NS1 antigen. If you only see that control line, the C line, that's a negative result. Now, that C line is super important. It's the built-in quality check. It tells you the test itself is working properly. If you don't see a C line, it doesn't matter what else you see. The test failed, and you have to do it all over again. Now, this tool is obviously incredibly powerful, but like any diagnostic test, it's not perfect. It's really, really important to understand its limitations so it can be used responsibly. Okay, first and foremost, this test is just one piece of the diagnostic puzzle. It's not the whole picture. A doctor has to look at the results along with all the other clinical signs. Also, if someone's had dengue before, there's a small chance it could cause a false positive. Of course, handling the sample correctly is vital. Any mistake there can throw the whole thing off. And finally, this test can tell you if you likely have dengue, but it can't tell you which specific type of dengue virus it is, and that can be important information.
And, that really brings us to the big takeaway here. These incredible little tests give us crucial answers with unbelievable speed, which allows doctors to act fast. But they also remind us that a diagnosis is always so much more than just a line on a piece of plastic. The real art of medicine is about balancing that quick data with the complete human story of the patient. Thanks for digging into this with me.